Hey everybody, hope you're doing well. Welcome to Geology. The next module is going to deal with flooding in rivers. So I want to throw a little bit out there to start because we got to be specific with this discussion. So let's talk what we're looking at here. This is the Salmon River, so this is, as you're looking at me that way, into town, not too far away from where I teach high school. But wherever you are, if you go and you find yourself a river, what we want to think about here is, where does all this water come from? And the easy answer is uphill, because water flows downhill. And sometimes I ask that to start, especially if we're live and not over this silly camera thing. But if I were to say, where does all water flow? There's this conception in people's heads, and I bet you some of you are saying it right now, that it flows south. And water does not have to flow south. Water only has to flow downhill. In fact, this river right here is flowing towards the west over to Lake Ontario. And I don't know what that misconception is. I've always thought maybe it's because people hold maps like this and they conflate south with down because water goes down. But south, down on a map would be into the map, not south, right? Or maybe it's because there's some very major large rivers in the United States, like the whole Mississippi, that flows south. I don't know, but it's not the answer. The answer is water flows downhill, right? So if you were to walk uphill consistently here, eventually you're going to get to where you're like at some kind of ridge where you'd have to go back downhill again. Think about that. And there's an important definition hiding in there. And what it is either the watershed or the drainage basin. We can use those two terms interchangeably. Here is a map of the Salmon River watershed. Now it's broken down by a couple other things. This is from an environmental report. But Lake Ontario is here. There's town, so that area that's in dark blue right about there is where that webcam was. So again, if we walk uphill, you can get up into this whole region. Everything that's highlighted in green here, or encircled by green, is lands that when water lands, because it's raining right now as per usual, when water lands, it's going to flow downhill and eventually make its way through Pulaski and out the Salmon River. So it gets narrow here. You don't have to go too far this way and you get into the next little system. There's one called Grindstone Creek over here. And you don't have to go too far this way to get up into, I think it's Deer Creek and Sandy Creek and some things like that. But we got to keep that in mind, and we got to use that when we start to think about what you're going to be writing for flooding. What I want to very specifically avoid is detailed chats on meteorology. And I'm not saying that a lot on that list does not have to do with heavy rainfall. It absolutely does. There's no way you can't avoid it, right? But I'd say what I've had in the past that I'd like to avoid is very detailed meteorology reports. Since this is not a meteorology class, and at least there used to be a meteorology disasters class, we're going to leave that for them. What I'm more interested in analyzing and digesting here is, what is it about the where that water lands that led to the flooding? And sometimes, yes, insane amounts of water are going to lead to flooding, right? But what specifically about the geology of the river made that happen? Okay, so like how there's an idea of relief. What's the difference from the highest elevation to the lowest elevation? Is that like spread over a large area or over a small area? If you picture like water rushing down a canyon of a mountain in the Rockies, that's a lot of relief in a small area. So water is going to respond in a flashy sense. We got the Tug Hill over here on the side, so it's a little steeper over here in the eastern part of the basin, but it tends to get a little bit flatter over here. And there's also dams. So what in the basin maybe is there that humans have created to mess with natural water flow? There's multiple dams in these reservoirs are because of that, hydroelectric and flood control dams. So what changes there, or what just things that are in existence there may contribute or buffer flooding scenarios? So you see what I'm saying? I want stuff on the ground. I don't necessarily like, tell me that it rained. I know it rained, or tell us that it rained, right? But don't give me that it was a low pressure system with this kind of front because of this air mass and all of that. Tell me about what happened once the water hits the ground. Okay. There's others where maybe you got to think about human influence a little bit more. First, some are obvious because a couple of them are dams that burst. But still, don't just give me about the dam itself. Think about what the shape of the drainage basin is. This is going to be a little harder. If you're saying this sounds harder, it's maybe a touch harder. Give me stuff about the geology, the shape of the river, the shape of the drainage basin, and what it looks like. Also, like, think about human use. There's one on there from Maryland, Ellicott City, Maryland, if you choose that one, where the human use of the area has changed significantly through time. I'll go to another example that's not on the flooding list, but if you go to the Great Northern Mall area, which is only going to get bigger and bigger, I'm going to go back in time. Let's go back to 94, when I was in high school. Here's the Great Northern Mall area. So if you haven't been there, it's just south of Oswego. This is Route 481 that comes through. There's a Great Northern Mall, which isn't really anything anymore. It's kind of just closed down. On the other side, we had these buildings here in 94 when I was a high school student. Get rid of this, and this is just historical satellite archival images slapped onto Google Earth. So if I get rid of that, think about this. This is only 94. I know I'm probably a little older than most of you, but 94 is not that long ago. If I get rid of that, look how much this area has expanded since. If you're a raindrop falling towards the ground in, say, 1900, and then 1994, and then now 2023, you're looking at three very different scenarios. So how has the land use here changed, or in whatever city you may pick? And how does that impact what happens to a droplet of water once it hits the ground and has to move towards those river systems? All right. Now, some of these themes we'll unpack as we go through the unit. If you do your discussion and then you realize, boy, I didn't do that right, if you're participating in it and trying, I'm appreciative and happy, and we'll sand off any edges on it as we continue to learn as we work our way through this course segment. But that hopefully is enough to get you started. Hope you're all doing well, and we'll figure out how to stop this video. Thanks, everybody. Take care.